Section 9.2, pressure. Pressure is a measure of how much force is applied over a given area. Pressure is force in newtons over area in meters squared, and the unit for pressure is the Pascal. And 1 Pascal is 1 Newton per 1 meter squared. Let's look at an example. A car screeches to a stop. It decelerates at -8 meters per second squared, and the 75 kilogram driver is stopped by her seatbelt. Find the force needed to stop the driver. This goes back to Newton's second law. Net force equals mass times acceleration. 75 times -8 be 600. -600 newtons, and that negative would just indicate the force is in the same direction as the acceleration. If the area of the seatbelt is 80 square centimeters, find the pressure on the driver's torso. The first thing that I'm going to do is take area and convert it to square meters. To do this, I'm going to remember that there's 100 centimeters in 1 meter, and I'm going to square both the top and the bottom of my dimensional unit. So I'll take 80 divided by 100 twice. Divided by 100, divided by 100. I get 0.008 meters squared. Then to solve for pressure, pressure equals force over area. I'll take my force of 600 divided by the area of 0.008, and I get 75,000 pascals. Find the pressure on the driver's body if she is stopped by 2 square centimeters of body area. I could repeat the entire process for part C, or I could realize that as the area is divided by 40, if the area is divided by 40, the pressure will be multiplied by 40. So I can take the pressure from part B, multiply by 40, and I end up with 3 million pascals. Estimate the pressure of her feet on the ground. Assume her feet have a total area of 160 square centimeters. Well, once again, I'm going to convert to square meters. So 1 meter equates to 100 centimeters. I'll square that dimension. That gives me 0.016 square meters. So the pressure of her feet on the ground is going to equal the force of her feet on the ground, which is her weight, which is 75 kilograms times 9.81 meters per second squared. And then I'll divide by the area, 0.016 meters squared. And we end up with a pressure of 45,984. And if I go to sig figs here, it's about 46,000 pascals. Now, the reason that I wanted you to look at part D is I wanted you to get a sense of what a pascal feels like. It turns out that 46,000 pascals would be the equivalent of somebody your size standing on your chest. So when we go back to part B and we look at the force, 75,000 pascals, that's a little bit like 2 people your size standing on your chest. Now, in this kind of a collision, that type of pressure, the pressure of two people standing on your chest, would certainly injure you and certainly cause bruises, but you probably would survive the accident. Without a seatbelt, however, 3 million pascals. 3 million pascals, I'll just do a quick calculation here. That's equivalent to 65 people your size standing on your chest. And that is probably not survivable. And this is why the devices in our cars, like seat belts and airbags, they increase the surface area and decrease the pressure in the event of an accident, and really do a lot to protect our bodies and prevent injury. A fluid can exert a pressure over an area. This principle is used in hydraulic lifts. So in this picture, what we have is a closed system, and this is actually more like a tube filled with fluid, and when I press down on the left end, the right end will go up. And it turns out that the pressure on either end remains constant. So if I do a substitution, since pressure equals force over area, then the force over the area on the left should equal the force over the area on the right, which means I can greatly increase my force on the right-hand side by increasing my area. Now there's a trade-off to this. I want you to imagine this tube filled with fluid, and what happens to this amount of fluid when it travels through and comes over here. It spreads out. It spreads out and it becomes wide but not as deep. So we're going to have a distance trade-off. And in fact, this acts like a simple machine. We're able to exert a greater force over a smaller distance using this simple machine. Let's look at an example. A car weighing 12,000 newtons sits on a hydraulic press piston with an area of 0.9 square meters. Compressed air exerts a force on the second piston, which has an area of 0.2 square meters. How large must this force be to support the car? So on one side, we have a force of 12,000 newtons and an area of 0.9. Our second force is unknown, and our second area is 0.2. So I'm just going to use my ideas of hydraulics, that the pressures will be constant. Therefore, the force to area ratios will be constant. So to solve this, I would cross multiply and divide. So we would get 2,667, or with sig figs, about 2,700, newtons, not pascals, newtons of force.